Hello, welcome back. Today we're going to be starting us off in lesson 2 of trigonometry with the Pythagorean identity. Now, you may or may not have seen it already, but it is basically sine squared theta plus cosine squared theta is equal to 1. Now, what is not a proof for this? Well, you may have heard that, the equation of a unit circle is x squared plus y squared equals 1, and we know x is cosine theta, and y is sine theta, so we plug that in, and we get sine squared theta plus cosine squared theta is 1. This is not a valid proof, and why? Well, if you know how to prove that the equation of a unit circle centered at 0, 0 is actually x squared plus y squared equals 1, you'll know at least one way to prove it. I think this is the only way. I don't know for sure, but it is definitely one way to prove it. That you have to use parametric equations, but more importantly, you have to already assume this is true. You have to have proven the Pythagorean identity in the step. Otherwise, you'll just be left with x squared plus y squared equals sine squared theta plus cosine squared theta. So we're going to have to prove it in a different way, right? We can't just use that x squared plus y squared equals 1 because that itself actually kind of, assumes what we're trying to prove. And remember, circular arguments, none, we do not do that. So proof. The easiest proof by far that I know involves doing the following. Let A be the point of intersection of the terminal ray of theta and the unit circle centered at O, which is 0, 0. Then A is cosine theta, sine theta by definition. Remember, we covered this in the last video, what the definition of sine and cosine were. Since the distance between A and O is the radius of the unit circle, kind of visualize this. We have here, we have O, and we have A. What is this distance? It's the radius of the unit circle. So the length is 1, and by distance formula, the distance from A to O is 1, but it is also the square root of sine theta minus 0 squared plus cosine theta minus 0 squared, or it's the square root of sine squared theta plus cosine squared theta, or in other words, sine squared theta plus cosine squared theta is 1 squared, which is equal to 1. So we've proven the Pythagorean identity. So this is going to be super useful. There are also some other ones that come along with it, which are, you don't have to know this right now, we'll cover it later in another video. 1 plus tangent squared theta is secant squared theta, and 1 plus cotangent squared theta is equal to cosecant squared theta. Both of those are derived from our original Pythagorean identity. Okay, this is quite a mess, isn't it? Well, I'll try to help you make sense of it. We're going to try to figure out how in the world are we going to find sine and cosine and tangent and cotangent and secant and cosecant of a random value that I give you. Let's say I want to find sine of 7 pi over 5. How are we going to do that? Well, you have to have some angles already known, and we want to minimize this as much as possible. There are a lot of approximation techniques for sine and cosine and all that. There's the Taylor series, which is in theory perfect, but it goes on infinitely. There's some other approximations that aren't perfect because they're just approximations, but they're really good. I would say, however, the important thing to note here is that that's kind of not useful. For that point, you would just put it into a computer, figure out an algorithm, whatever. We're only going to be covering angles that have some relation with either pi over 2, pi over 3, pi over 6, or pi over 4. You know sine and cosine of these 4, and everything else follows. But why? Well, we're going to show techniques. Let's let x be between 0 and pi over 2. Now, x is going to be called our reference angle. Why? Well, because for any angle at all, every angle has a reference angle. And of course, if the angle is just between 0 and pi over 2, if it's in the first quadrant, then it's just its own reference angle. The reference angle is basically its own angle, like let's say the reference angle of this whole thing, or sorry, the reference angle of this whole thing is just x. But why? We're going to cover that right now. So first, we'll let the point of the x point formed with the intersection, we'll denote that p sub x of a comma b is cosine comma sine. We already talked about this and why this is true. Well, what happens if we look at this angle right here? What is this angle actually? Do you know? Well, it's pi over 2 minus x. Since this whole thing is pi over 2 and this is x, this is pi over 2 minus x. Those are some geometry. Hopefully you remember. And how do we prove that? Okay, so we don't actually know that this is true, but let's just show it, okay? Well, can we say these two triangles are congruent? Do you remember? Well, this is 90, and this is x, and this is x. Remember, we said this. Well, and this is 1 and this is 1 because they're both radii of the inner circle. So can't we say by angle side congruence theorem that these two triangles are congruent? And doesn't that mean that this is equal to this and this is equal to this? Yeah. So this length, which is cosine, is equal to here. So in other words, the x-coordinate of this point is the y-coordinate of this point, and the y-coordinate of this point is the x-coordinate of this point. So this point is b comma a, which is sine comma cosine. And over here, we're going to do the same exact thing for this angle, which is pi over 2 plus x, because we have pi over 2 here, and here we have an x. So we have pi over 2 plus x. In this case, I'm not going to be constantly repeating the proof. I think it's pretty common sense. Right here, we just have the negative of this point, the negative x-coordinate of this point, is a reflection over the y-axis, but it has the same y-coordinate. So it's negative cosine x over comma sine x, And this is pi minus x. Remember, x is a reference angle. So this is where x is going to be. This is the measure of x. Here's a reference angle x. So this is pi minus x, right? This is the actual big angle with a reference angle x. So this is negative a comma b, which is negative cosine x comma sine x. Here we have point formed. The point formed with the angle pi plus x is negative a comma negative b. So remember, this is x, and this whole thing, which is a straight line, is pi. So from x, we reflect all the way over a straight line, pi. So of course, we're just going to get negative a comma negative b. So negative cosine comma negative sine. Here we have 3 pi over 2 minus x. So 3 pi over 2, which is this whole thing, minus this, which is just this, of course, more geometry, which is minus b comma minus a, or negative sine comma negative cosine. Finally here, 3 pi over 2 plus x. 3 pi over 2 plus x is this whole thing, which is b comma negative a, which is sine comma negative cosine. And finally, since this whole circle is 2 pi, if we subtract this x, we get this angle, and it is, of course, a comma negative b, which is cosine comma negative sine. The point of this is to derive the things on the right that I'm about to show you. Don't worry, I know you've been seeing it. Kind of looks scary. Don't worry, it's gonna make sense. Hopefully. But seriously though, the point of all this is to find the reference angle. So if I give you an angle here, let's say, and we have to first find the reference angle x. So how are we going to do that? Well, this angle can be expressed as 3 pi over 2 minus x. So x is a reference angle. And here's how we're going to use that to our advantage. Because Notice that this, cosine comma sine and negative cosine comma sine, they're very similar. In fact, if we know what cosine and sine of x are, as long as we use the right, whether it's negative or positive, or if, what order, as long as we know what cosine and sine are of this angle x, we can figure out all the rest of them pretty easily. So this is what all this is for. Now, don't get scared. It's not too much. In reality, it's just 2 per angle. And since we have 1, 2, 3, 4, 5, 6, 7, 8. 7 because we're not counting this. We have 14 total. But it's not actually too hard. And I'll explain how. You don't really have to memorize it. I mean, you should memorize it, but it makes pretty much sense anyways. So, what is cosine of pi over 2 minus x? Well, it's cosine of this angle, so it's, remember, the x-coordinate of here. What is the x-coordinate? Well, we know it's b, right? What is b? Well, b is this. B is sine of x. So, cosine of that is sine of x. Done. What about sine of here? Sine is the y-coordinate, which is cosine of x, which is a. A is the y-coordinate, right? And a here we know is cosine of x, so this is true. So in other words, cosine of pi over 2 minus x, or sine of pi over 2 minus x, is just equal to the other one, sine or cosine. Now what about cosine of pi over 2 plus x? Well, what is it? Well, it's right here. Well, what is the cosine of this? Is the x-coordinate, which is negative b. What's negative b? Well, it's b is here, sine. So negative b is negative sine, which is how we get this. Sine of pi over 2 plus x is negative cosine x. Notice here, sine is the a, which is the y-coordinate, which is just cosine x. I believe in that case, yeah. In that case, it is just positive cosine of x. If I'm not mistaken. Yeah. So cosine of pi minus x is negative cosine of x because, well, this is pi minus x, right? It's pi minus x. We talked about why this angle is pi minus x, which is right here. So what is cosine? It's the x coordinate, and x coordinate is minus a, and minus a is minus cosine. So all of these, I'm just doing the exact same thing, tracing it back all the way to our reference angle. So you see why it's so important to know what the value of the reference angle is. Because in theory, what if we're given, find cosine of 7 pi over 6. How do we figure that out? Well, we're not going to memorize cosine of 7 pi over 6. That's crazy. But we do know where in the coordinate plane is this? What quadrant? Well, you'll kind of get a sense of this, but 7 pi over 6 is above pi, but below 3 pi over 2. So it's in our third quadrant. So it's going to be our reference angle plus pi. So it's cosine pi plus what? What gives us 7 pi over 6? Well, what's 7 pi over 6 minus pi? Pi over 6. So our reference angle x is just pi over 6. Do we know cosine of pi over 6? Well, first, what is cosine of pi plus pi over 6? Well, let's go all the way over here. Cosine of pi plus x, negative cosine of x. So negative cosine of pi over 6. So you see how we use this. Now we've split it into a much easier problem if we know what cosine of pi over 6 is. So how do we figure out what these are? Here's where you need to memorize it. Now you may remember from geometry what a special right triangle is. I'll try to do my best here to make them, but of course it's not going to come out nice. Okay, there we go. It's 1 and there we go with the other one. Let's say that these are both pi over 2, pi over 2, pi over 3, pi over 6. Remember, the ratio is 2 is to 1 is to root 3. So it's just x because it's a ratio, but that's the ratio, of course. And I remember learning that we already proved the property that for an angle between 0 and pi over 2, we can use opposite over hypotenuse and all that stuff for sine and cosine. So what is sine of pi over 6? If this is 2 is to 1 is to, 2 is to 1 is to root 3. Well, what is sine of pi over 6 is 1 over 2. What is cosine of pi over 6 is root 3 over 2. What is sine of pi over 3? Root 3 over 2. Cosine of pi over 3, 1 over 2. And the same thing for an isosceles, where this is pi over 4, pi over 4. You just need to know that sine and cosine of pi over 4 is root 2 over 2. Another way of memorizing this is the following table, and if you use it enough, eventually you'll get it. So you start off with the angles. You start off with the angle 0, pi over 6, pi over 4, pi over 3, and pi over 2. So sine, cosine. So we start writing sine 0, 1, 2, 3, 4. And cosine, we work backwards 4, 3, 2, 1, 0. But obviously sine of 0 and the sine of 0 is 0, sure, but sine of pi over 6 is not 1, and sine of pi over 4 is not 2. That's ridiculous, right? So the key is, this is a pretty cool trick. You have to take the square root and divide by 2. Square root and divide by 2. Square root divide by 2. Square root divide by 2. Square root divide by 2, and do the same thing here. And that way, we can figure out all the values. So in other words, we get this table, 0, pi over 6, pi over 4, pi over 3, pi over 2. We got sine, we got cosine, we got sine of 0 is 0, cosine of 0 is 1, sine of pi over 6 is 1/2, cosine of pi over 6 is 3 over 2, sine of pi over 4 is root 2 over 2, cosine of pi over 4 is again root 2 over 2, sine of pi over 3 is root 3 over 2, cosine of pi over 3 is 1 over 2, sine of pi over 2 is root 4 over 2, which is 2 over 2, which is 1, and here it's 0. And remember, by the way, this is just a happy coincidence. Like, come on, how could it not be made easier for you? It's just lucky that this is even true. Because, well, really, and actually I'll leave the table for you if you want to use it. I'll erase this part. Because really, this doesn't work for other values. It's just a happy coincidence, really. But you do need to know this table, by memory. So back to the question, if I give you cosine 7 pi over 6, how would you find it? Well, first find the reference angle. So in this case, the reference angle is pi over 6. It is pi plus that, which you don't have to memorize this whole thing. Don't think of it as memorizing. Try to visualize the unit circle. What would pi plus pi over 6? You need to know pi plus pi over 6 is going to be right here in the third quadrant. It's going to be here. You need to know that. That you need to know. What would this look like? Well, it's going to be negative cosine, negative sine, right? It's just a straight line through. So we're going to get negative cosine pi over 6. You'll use this enough and get used to all these values. And remember, we know what cosine pi over 6 is. What is cosine pi over 6? Root 3 over 2. So it is negative root 3 over 2. And that is how you would find the value of this. I have to say, very useful. Very useful indeed. So, in general, that's how you would how you would find the reference angle and how you would use it to find sine and cosine. And from there, we already established, we already proved tangent theta is sine theta over cosine theta. We didn't prove, but we know that secant is 1 over cosine, and cosecant is 1 over sine. Cotangent is cosine over sine. So since we have cosine and sine, the rest come naturally. So thanks for watching. Hopefully this helped you out. If you had any thoughts or concerns, and if you still do, feel free to reach out to me. And I'll try to answer any questions that you may have. Of course, this is lesson 2 of trigonometry, and I'm